All right, we got a brand new bite of the whale today. It is called, let me double check the name of the assignment here. It is called Linear Equations, Word Problems, Graphs. Linear Equations, Word Problems. Incidentally, what are you doing right now? You are writing the name of the assignment that you must complete at the top of your page. There's been a lot of people who have said, Mr. Wolf, I wrote down what I was supposed to. You're expected to write this down. You are expected to write this down. You will get points in this particular case for organizing your binder. That's not participation. I'm trying to teach you how to organize your notes in a way that you can study for a big test like a final. So that's the reason why I'm grading your notes in this case. Your organization and your study plan for the final. That's going to come when I get back on Thursday and Friday. You are expected to write this down. I'm glad that you wrote this down, but you still need to complete the assignment, and that assignment is still graded for correctness. Okay, so we're starting off with a battery is charged. We got a graph here, and I'm reading, starting right here, a battery is charged. The percentage of the battery's capacity, that's how much the battery is holding, like a cell phone, that is charged as a function of time, is graphed. So this is just a cell phone, like a little meter on your cell phone. Down here, here's the little meter, and the little meter down here is at 40%. And it's got like a lightning bolt on it because it's charging. And then up here, it's 100%. Okay, so the little meter on your cell phone is growing from 40% charged up to 100% charged, and that's what our problem is about. And it asks, what was the battery's charging level when the charging began? Well, that has something to do, begin is another word for the start. So we want to know where the charging began, that's where it starts. It starts when the time is no minutes at all, obviously this is 0. So this is the start right here. When charging began, the meter was at 40%. Okay, so no big deal. Charging began at 40% in there. Okay, next question. While exploring, so I'm going to this one over here. While exploring a volcano, Zane heard some rumbling, so he decided to climb up out of there as quickly as he could. Zane's elevation, that means where he is up and down, relative to the edge of the inside of the volcano, as meters, as a function of time in seconds, is graphed. Okay, so Zane is at the bottom of this volcano, and he's going to climb out of there as soon as he can because it's about to explode. We want to know all the way down here, how high did Zane climb every 7 seconds? So if he were to start here, and he were to go for 7 seconds, and stop right about there, then how far up did he climb? How far up did he climb? So as you can see, it's going to be something like, let's see, that's 25, that's 20. So it's a little bit less than 5, because he doesn't quite get to 20, but I need to know exactly what it is. So I'm going to figure out first, how far does he climb each second? Okay, so how far does he climb each second? Well, that is the slope. So every time the second goes up by 1, how much does the elevation increase? So in other words, how far does he climb each second, each 1 second, every second, per second? And for that, I'm going to divide the rise by the run. Now, the slope triangle in this case is really easy. I'm going to start here and go all the way up to 0, and then go all the way side to side to 35. Just like that. No problemo. Okay. All right, so that's from 0 to 25 is 25, and from 0 to 35 is 35. So the rise over the run is 25 over 35. And that's each 1 second. You can simplify that. It simplifies to 5 over 7. So the important thing is that this is per 1 second. So this is for 1 second. So each one of these goes by 1. And so for 7 seconds, you would want to multiply that times 7. And that's going to give me for 7 seconds. So this is how much for 1 second, each second, times 7 seconds gives me how much it is going to, how far he's going to climb in 7 seconds. Now, if I was really good at simplifying, I would do 35 divided by 7 is 5, and then 25 divided by 5 gives me 5 over here, but I'm not good at any of those things, so I'm going to put them in a calculator. 25 over 35 times 7, I just put the whole thing in, and it gives me, of course, 5. I wish I could scroll over there. I'll just make it bigger. There. So the 25 divided by 35, that's the slope. So that's per 1 second times 7 seconds gives me how far he travels in 7 seconds, and that's going to be 5. And so my answer here is 5. And this is really tricky. It's going to come up. This kind of problem is going to come up over and over again. A battery is charged again. The percentage of the battery's capacity that is charged as a function of time is graphed. At what rate is the battery charged? Okay, so the last question asked us for the star. So let me look again. This one, where was it when it began? That was the star. And then this one down here. It wants the rates, and the rate is the slope. So the last one wanted the star. This one wants the triangle. So, wow, there's so many good dots to put. I'm going to put the one that's way far away. So I'm going to go as far as I can well, I mean, as far as I can, but farther than just the nearest one, because I find it to be more accurate when I go further away. So what I mean is this is a good dot, this is a good dot, this is a good dot. So which one do I pick? I just went ahead and pick this one out here. So I'm going to go from here to here. And let me remind you, okay, so a lot of people are going to be tempted to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. They are all wrong because we are going to stop counting squares. Okay, I'm going to explain why again. The reason why is because these numbers over here aren't number 1, number 2. So if I count the squares, I go 40, 41, 42. I'm at 40. No, you're not at 42. You're at 50. 50, 51, 52, 53, 54. No, that's not 54. It's 70. If you count 1, 2, 3, 4, it's wrong. Stop counting the squares. That's totally wrong. What am I going to do? I'm going to look at the numbers instead. So from here to here, it goes from 40% charge to 90% charge. That means it charged by 50%. And then how long did that take? It went from here over to here, from 0 to 25. Well, that's 25. And now that I've stopped counting the squares, I can get rid of that. And so let's go ahead and do the rise over the run. 50 over 25 is, of course, 2. 2% per minute. Okay, so that gives you an idea of how fast your cell phone charges. Your cell phone charges about 2% each minute. That'd be a very handy statistic to measure on your cell phone. Maybe we will someday. That'd be a good idea. Suraj took his frozen pizza out of the freezer again and put it into the oven. It's down here and it's -5, so that's past freezing. The pizza's temperature in degrees Celsius is a function of time is graphed. How long was each increase by 4 degrees Celsius? So we want to know how long did it take to go from here to here, a little bit less than 5. Now for that, we need to know what the slope is. In other words, how long is it going to take for 1 degree change in Celsius? So let's do the rise and the run. I don't know, you know what? Let's just go ahead and figure this out. So let's do it on the graph. I'm going to start out right here, and to increase by 4 degrees Celsius, I'm going to wind up somewhere about right here. So this is how to do it if you have like a multiple choice. Notice that I didn't go all the way 5. This would be from here to here would be 5, so that's about that far. I went a little bit less than that far, so I went up by about 4 degrees. I'm going to go sideways to about right here. And let's figure out how long that was. This would be half a minute. And so this would be 0.75 of a minute. And so my answer is going to be between 0.5 and 0.75. And I'm going to go ahead and estimate that. I'm going to say it's 0.6. 0.6. So it took 0.6 of a minute to rise every 4 degrees Celsius. And that's called an estimate. And that's fine. Estimate. You want to go ahead and do the calculation? Let's do the calculation too. I'm going to draw a rise run triangle. This is a good dot right here. It's going to go up to about, whoa, what was that about? It's going to go up to about right there, and then it's going to go over to the next good dot, which is right around there. So that's 10 degrees. So this is from 0 to 10, that's about 10 degrees rise. And this is from 0.125, 0.75 to around right 2. So to go from here to here, to go from 0.75 to 2, that's 1.725. And you can use a calculator for that. 0.75, 2 minus 0.75 is about 1.25. So the rise over the run is equal to, okay, so this is a ratio. It's 10 degrees per 1.25 minutes. I don't know how long the next one's going to be, so that's going to be x. So how long is unknown? And then 4 degrees is the temperature change. So the ratio 10 degrees is 1.25 is the same as 4 degrees over x. And now I can do crisscross applesauce. So 10x equals 4 times 1.25, that's 5. 4 times 1.25 is 5. And then I divide by 10. Oh, and it looks like I got it wrong. 5 divided by 10 is 0.5. So the correct answer should have been 0.5. My estimate was 0.6. And just by kind of stupidly looking at it and saying, okay, well, if I go up 4 degrees here, I go about 0.6 degrees over. So if I go up 4, I go over 0.5. So I could have gotten the answer that way without doing the crisscross applesauce. Okay, next question. Okay, what was the pizza's temperature after 2 minutes? So here's 2 minutes. The temperature is right here. It was 10. I'm going to start speeding up a little bit. So 2 degrees, 2 minutes, it was 10 degrees. Blah, blah, blah. I want to get the slope on this one. Archimedes put water in the tub and it drained out this fast. Let's get the rise and the run just because I know that we can. So here's a good dot here, and here's a good dot down here. Stop counting the squares. So it goes from 0 to 360, so that's 360 in 5 minutes, in 5 minutes. So that's 360 over 5. Liters per minute are draining out of there. And I can put that into a calculator. I get, let's see, 72 liters per minute. Okay, so now we can read the question, see what it wants. How long did it take 18 liters to drain? So how long did it take each time 18 liters were drained? It's exactly the same as the crisscross applesauce, but we saw, hopefully you saw how difficult that was to do the crisscross applesauce. So you're just going to guess from that one. So how long did it take to go from 360 down to, let's just say 340, because it wants 18 liters to drain. So that's 360. It's going to be a little bit before 340, so it's about right there. So how long did that take to drain from here to about right there? Took, okay, so that's 0.25. So it took about 0.25 for it to drain that much. Okay, so that is 0.25. Okay, so in other words, to go down by 18, you have to go sideways by 1.25. How long did it take to drain 18? Down 18, sideways. How many? 0.25. So the answer here was 0.25. Okay. How long did it take him to reach the edge of the volcano? Well, the edge of the volcano is here, and this is where Zine reached the edge. And so it took him 35 seconds to reach that edge. And then Carl's driving this truck. Good for Carl. How much fuel does he consume every 100 kilometers? So I hope that you get the idea of here. Okay, so kilometers is this way, right? So how much fuel does he consume every 100 kilometers? I'm setting up a triangle that goes sideways 100. Okay, so just like this one here. With Archimedes in his pool, I was setting up a triangle that goes down by 18 liters. So liters was this direction. So I looked this way to go down by 18, and then how far side to side would I go? So this little triangle was the itty-bitty triangle that went down 18 and sideways 0.25. Now this triangle that I'm setting up is going to be a little bit bigger, so I wanted to slow down when I was doing it. It's going to go 100 kilometers. Now kilometers is down this way. So my triangle is going to go from here to here, and I'm going to approximate how far the triangle goes from there to there. So from here to here, here's my triangle right there. Here's my triangle. Here's my triangle right here. And as you can see, it's a little itty-bitty triangle. How far down does it go? How much fuel does he consume? So if he had 500 and he went down to here, how much was that? Well, that would be 425, so it's a little bit less than that. So I think this would be 50. From here to here would be 50, so he's consuming a little bit more than that. So I would say around 6 liters. Okay, so let me do that again because it was a little bit confusing. Oops, I'm trying to erase. So it's asking us about 100 kilometers, right? So here's 100 kilometers from here to here. From here to here is 100 kilometers. Every time he goes sideways 100 kilometers, how much up and down does he go? Well, this would be 50, so it's a little bit more than 50, it's 60. And that's the reason I chose 60. So the triangle goes down 60 and sideways 100. And that's my answer for that one. This was the lecture notes on the assignment called Linear Equations, Word Problems, Graphs. And there are 2 more assignments that are due by next Friday.